Hey there. And we're live on Instagram too. Hey, check that out. This is cool. I'm super psyched today. We are back. I have access to our Instagram account on the app, not just through Canva. So I've been super fired up all day. We've been doing a lot of things, organizing behind the scenes, and I am super pumped to share some things. So if you are catching this live stream on Instagram, you can now find links in our bio to find us on Twitch, to find us on Twitter, to find us everywhere else. That was one of the things I got to fix today. And yeah, that's cool. You'll also be able to find our website and find our programs and find ways to connect, ways to sign up for Masterclass. We have a wonderful sponsor. Masterclass has granted us access to the Masterclass platform to give veterans a free year to use their learning tools. What else is on there? Oh my gosh, our clever partner. It's a prescription benefit plan, and we can share it. So please go check it out. But if you are catching this, that also means you can come watch me in person, either on Twitch or on Streamlabs Charities. And I dig both programs. If you have a Twitch account, come on over and follow us. That would be cool. That would be fun. And you'll get to see this more often. And you get to see more than 4 minutes, because the rumor is we have a 4-minute time limit, because this is not streamed through Instagram. It's streamed through an RTMP server. Basically, there's this little app on my desktop that catches this Twitch stream and sends it to Instagram, but the app I have has a 4-minute time limit, so we're halfway through. I have no time limit on Twitch. I can stay here all night. You will be stuck with me there. But in all seriousness, before I get to some music, crank some things up, I'm going to take the next 90 seconds to talk about our design contest for this month. It's a challenge. I keep calling it a contest. It's really a challenge. I am challenging everyone to do the things that I do, because they're not really that hard. And this month's challenge, because it's August and we'll be talking about back to school, is to design your own pencil grip. You can do it right here in Tinkercad, which is something I'm going to break out in a minute. If you don't know what Tinkercad is, go to our website, go to the resources page, go to our events, sign up for a Tinkercad workshop with me. I will get you 3D printing. Once you see the 3D printing process happen in that workshop, you will share the file that you make with me, and I will print it and I will send it to you. That's pretty much how it works. I like to prove that what you do matters, what you do actually works. So if we can work out a plan to do that is wonderful. So if you already know how to use Tinkercad, super. I'm not going to dwell too much on it, but just to give everybody an idea, I will be printing the pencil grip out of a flexible material called thermoplastic polyurethane, or TPU, and it looks like kind of like a Twizzler, and it prints all kinds of cool stuff like flexible, so it could be a pencil grip. And I'm about to lose my 4-minute mark, so what I will sign off with on Instagram is come over to Twitch, go in the bio, find us. I do this frequently. And there they go. They're off. So for anybody who catches this on Twitch or anywhere besides Facebook and Instagram Live, the screen is like this. It's like that tall screen, so I have to sit right in the middle, right here, and I can only do this. So I'm stuck in this little box. Help! I'm in a box. Let me out. Austin Powers joke. It's a line from an Austin Powers movie, if you're old enough to remember it. If you're not, no heckling. Thanks. So I'm going to crank up some music real quick. I'm actually going to do it on my phone. And I'm going to Actually, we're gonna skip the music for tonight. Well, maybe I'll find some YouTube music very quickly. But tonight, I wanted to briefly remind everyone about our design challenges, and say that we still have over half the month to design it. The Tinkercad workshop, Tinkercad modeling, I believe, is what the official title is. At the end of the month. And give me 1 second. Go back. YouTube, retro. I have one soundtrack that I've been listening to for a long time. There it is. Commodore 64. Was this game R-Type? It's old school music. I don't ever remember playing this game, but it looks. Ooh, I'm not going to sit here and stare at it. But it is on, and it looks like you can hear it. So that's awesome, super cool. Yeah. So back to the design challenge. This flexible TPU is easy to print with. I do a lot of other printing with it, and we just got a huge shipment of filament for my 3D printer, so I'm excited to print things for people and do stuff, and I'm going to turn down my kickin' jams just a bit. How about that? Cool. Alright, so I don't have to yell over it. Excuse me. I've been eating a lot today. I don't know. I'm training for a marathon, so I started eating a lot lately. In the last, I don't know, 6-8 weeks of the training cycle. But it's enough about me. I have babbled on about me for this whole time. So go to our website. You can go to our website, and at this point I'm going to share my screen. And I say share my screen because I've been in workshops today. What's actually going to happen is there. Oh, poof! I'm at Google. I go to our website, weliftandshift.org, and I click on resources, and I click on the very first thing right here, this month at Lift and Shift, and there you go. You can find our August events and resources, and if you scroll down, you'll see that there are a lot of things going on. There are design contests, the challenges, and some of the workshops here. We also have partners, our partner Clever RX, which is supporting veterans through a prescription benefit plan. Yeah, it's not insurance, but it's a one of those prescription cards, and they're supporting us with a partnership that gives us the ability to offer a prescription healthcare plan that we can share with everyone. And if you go to our website, you'll see it there. You'll be able to click some links and even download an app or search for the prescriptions that matter to you. Amazon Smile, Giving Assistant, obviously places you can shop and support our programs without ever having to lift a finger or donate anything to us. Back of my head is there's this fly. I bought bananas and a fly came home with the bananas, and it's just been like buzzing in my ear all day, driving me crazy. I put some bleach in a spray bottle, and hopefully I'm killing it, but I feel like it's going to take forever. Anyway, that's it. So now we're going to get down to Tinkercad, and I have a project, so I wanted to share my project. I haven't done any design, any real like modeling in a while. So while I want to convey the importance of the design challenges, because those are the real reason I'm here, I also want to share some tips and tricks, and I stick with Tinkercad for a reason. It's free, it's accessible, and it's modeled as a software platform for anybody to use, even children. I use it to teach all kinds of people all kinds of things. It's a great beginning tool until you master the concepts of of 3D modeling and you want to move on to something with a little more oomph, you can go to Fusion 360, SolidWorks, 3ds Max, SketchUp. There's literally dozens of applications, but I stick with Tinkercad because it's free. It's something that people are familiar with if they work with me. They don't have to worry about new methods, models, interfaces, menus, any of that stuff. It's all the same. So as much as I appreciate some of the nerds, my fellow nerds, my fellow engineers and designers and people heckling me about stepping up my game to a real CAD program, I'm gonna stick with Tinkercad and take the brunt of the body blows on that front, because when it comes down to it, this is all about learning, and even the best people will be thrown when next year's model comes out with new menus and new buttons, and everybody's lost, and you gotta go to YouTube and watch a video about it. But I'm gonna stick with what Autodesk has done with Tinkercad. So thank you. And if you've seen any videos from me in the past, you've probably seen that I don't have a good 3D printer setup as far as sharing what it does. I have an Ender. It's an Ender 3 Pro, and I love it. I honestly love it. But I have it connected to my computer through the USB, so I don't set up an Octopi. And for anybody who's lost on those terms, it basically means there's a way to set up my Ender so that there's a box that has a camera that it controls, and it can take pictures as it's making 3D prints, and I can watch it. I can make cool videos and stuff like that. But I can't do that. I don't do that because I have my 3D printer hooked up, because I change my models so many times and do so many different prints with so many different materials, from TPU to PLA to PETG and on and on and on. And I make all these quick edits to models and test new settings. So I keep Cura open usually 24/7, and just my poor printer is a workhorse. I'm considering getting a new one, but until that happens, I need to come up with a better way to make videos about the 3D printing process. So I've been thinking about this for a bit. I picked up a spare Pixel phone, Android phone, on eBay, and I'm going to use that as my new camera. So I need a camera mount, and my printer is on one of those 3D wire shelves, so I really just need a swing arm that I can mount a camera or a phone clip to. So it's really not that complicated. I already have a selfie stick here, so I can dismantle it and take off the phone grabber part if that's what I want to do. I've got several GoPro arms around, so I can also change my GoPro setup and set it up so that my everything's working differently, basically. But I'm going to cross that bridge when I get to it. Right now, I want to make the swing arm, and I thought that would be a great thing to do tonight, is to hop into Tinkercad quickly and take a swing arm. So let's make it big. Pow! Can you see me? I'm way down here in the corner. Alright, so I've done this in the past. I made this arm right here. Let's zoom in on it a little bit. Make it big, make it the center of attention. So this is an extendable arm, 2 parts, that clips onto the side of my wireframe shelving unit. And that's where my 3D printer is sitting. So right now I want a swing arm right on the same post that this is attached to. So since I've already got this, I'm going to kind of hack it for the measurements. I'm going to pull these apart. I'm actually going to slide those down that way. And now I'm going to grab this one piece. I'm going to duplicate it, because I want a swing arm like this, like a 2 pieces. So I'm going to make one swing arm that I can duplicate, so I can make it extendable, piece by piece. And then I'm going to make a bracket that mounts on the post. And believe it or not, this is the perfect bracket. So I'm going to duplicate this again. And I love the duplicate feature because it moves things the same distance when you duplicate it. So you see I had this part and I duplicated it and moved it down here, and then I clicked duplicate again and I moved it the same distance away, so that I always find that amusing. But I'm going to take this apart and you will see what I'm doing. I'm making the rod, or the clamp, so you can see right there how I put this together. And I'm going to get rid of this for right now. I'm also going to, let's dive in here because I need to get rid of that little ring. Like that. So this is going to be my post. And this fits tremendous. It fits perfect on my post as it is right now. But I need another ring to make things happen. So I'm going to duplicate this once, twice. Actually, we're going to do it 3 times. Okay, cool. I'm going to set it over there. So this is going to be the part that actually attaches to my post. Now I want another ring just like this. And this is over here for a reason, for later. And then I want my post to basically like go in these and have like a continuous swing arm. So that part is cool. I want to do that. But this looks a little creepy. I want to raise this up a little bit like this. But first things first, I can't raise it without... I have this floating surface here. That's not going to print very easy. So here's what I'm going to do. I'm going to... Actually, let me back up. I'm going to... I undid for a minute. I'm not going to go deep into the undo and all the features of Tinkercad. Here, I'm looking for the wedge. And I'm going to make it a hole. And I'm going to turn it so I can see it. 90 degrees. Like that. And now I need to size it so that it's basically a 45 or less. So let's see, how big is that? About 25 millimeters. So let's make this 30 by 30. Oh, 30 by 30 by 30. Okay, so now this is a 45-degree angle, or this is a 45-degree angle right here, and I can do this number. Okay, I like this to have a 45-degree angle because then it's easier to print. But I realize now I need to raise this up some. Nope, 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 nope. I gotta grab that one. Like that. Now also I need to lift it up a little bit to make this ring. Like that. And can I get away with lifting it up just a little bit more? Yeah, like that. I just don't want to, this is going to be in a corner, so I don't want a sharp edge sticking out like to jam me in the knee or something, because just like my kids' Legos, this will catch me somewhere. Cool. So I'm going to slice this up, join them, group them, it's called here. Let's check out the other side of this. Oh, I missed it! Undo. So I'm going to slide this over that way. Now redo. Cool. Now I'm going to turn it 90 degrees. Or, I'm sorry, 180 degrees. Spin it around. Spin me right round, baby, right round, like a right baby round. Never mind. 80s music. Stuck in my head. Let's do it. So I'm going to lower this a bit. In fact, I'm going to back up. I'm going to align these. this way, like that. That way I have this cool angle right there. Oh, I should have aligned it. I should have made another... actually, I can. Double click. Duplicate. Pull that out. That's a super awesome feature. I love it. Now, I need to rotate this. Once you see this, you'll understand what I'm trying to do. 80. Flatten. Get back on here. I'm going to grab these two and pull them away like that. I want to grab my part here and pull it to the side a little. Then get it over all the way. Actually, let's do this. Ready? Pow. Join these two. Now I've got this crazy looking ring. I'm psyched about it now, so I can move it back over. Yes! Now I can lift it up. Like that. And I'm just going to briefly mention the reason I like having this part so long on the touching the side is because of physics. So I'm just going to say it. We're going to be creating this rod that sticks out this far. And if we have a weight, let's say I stick a weight on the end of this, like that. The force down on this is not the force. The weight of this object might be I don't know, like 10 pounds, right? It's a 10-pound weight. Now, if it's a 10-pound weight pushing down here, it's just one straight vector of force. But because we're putting the weight on the end here, and then we're putting a pin inside here, we're creating other forces, and there are torques involved, and then that's where the distance of this rod adds to the weight here, and the 10 pounds could become exponentially heavier as an angle right here, and then it creates a weak point at the fulcrum. This is basically a lever, so the weak point at the fulcrum of the lever, and or the mount point, or whatever you want to call it. I'm using terrible terms because I haven't done this type of mechanics linear. In fact, this is like a whole semester-long class if you've ever wanted to get into mechanical engineering. These type of it goes beyond engineering mechanics, like statics and dynamics, into I believe it's called linkages. There's like a whole class on linkages, like chains and sprockets and gears and things. It's really fascinating to me, but yeah, just for reference, I like to have this part come down longer because of physics. Basically, that's the short version. Is that this rod here is without getting into all the math and torques and newtons and vectors and things, it's gonna add weight to this part that's on the end. So if I can, I try to make things longer on this part here. Short, very short, non-technical explanation. Hope that was not too boring. But I've got these parts now lined up, so I've got my bracket ready to go, and I'm going to grab it, join it, poof, So now I've got my bracket that's going to go on my wireframe. And as the wireframe, or as we move on to the next parts, we want to use this, and we want to make a swing arm. And this part is pretty much already done for us. We already have this arm, and we have half the loop right here. And just another note here. I created this part with angles that are so high that I won't have a problem 3D printing it. There's no tight overhang where I have to worry about it. There's this 45-degree angle going up. So my printer should have no problem printing this angle right here as a floating type overhang, which is another reason why I did this. I don't want to print it with a support structure. And if this does not work, then I have to go back to a flat surface on the top. I would go back to something like a flat surface like that, where I could flip it over and print it upside down on my printer with all the stuff there. But I kind of dig this thing, and I'm gonna test it out. This is a small piece, so I can go through iterations and iterations of it. What I really want to focus on now is the swing arm. So we're going to set this piece aside over here, because that I think is good and ready to print. Now the cool part about the swing arm is, if this is an extendable swing arm and I make this properly, I can print multiple ones instead of one long. Like this is like a 9-inch swing arm. This is a 9-inch arm, and maybe I want 9-inch, maybe I want 12-inch. I don't know. I'm not. I want to be able to add and remove length to it. So I want to make it like a scissors almost. So what I want to do actually is take this apart, and it's just going to keep getting in my way, right? And I want to shrink this down like that. And then I want a loop on one end and a pin on the other end. I want a basically something that kind of looks like that, so that this pin can go in my whoops, undo. So my pin can go inside this part over here, and that's really what I want. So right now we're very, very close actually. And if I do this with this 3-part, then this whole assembly right here I can print over and over and over again, and just keep adding more links as I need them. And this will look a lot like a I don't know, like a scissor jack or something. But I'm gonna set this aside, this pin aside for now, because what I need to do is alter this arm here. And if you remember, at the very, very beginning of this, I made this bracket the same size as this arm, which was a copy of one of these. So if I make this arm with the same dimensions here and don't change this, whoops. So for example, I leave that as my swing arm frame, then I'm very well off, because then all I need is to make sure this pin fits inside, just like it fits inside here, and then I'm good. But I'm going to delete this, and I'm going to bring this back over here, because I happen to know that when I made this, I made it out of this solid cylinder and a voided cylinder. So I'm going to duplicate this voided cylinder. Oh, first I'm going to back up. I'm not going to use that feature. I'm going to use the double-click feature, and I'm going to grab that voided cylinder and I'm going to duplicate it, and I'm going to put it over here. Now I'm going to click away. So I just got this back. I can make it a solid, and now I know exactly how wide this cylinder is. Excuse me. So in the context of Tinkercad modeling, I've kind of got this down. I'm going to add I'm just going to crank up the sides. And what is this? 1950. So here we go. Here's some interesting stuff. I need this to be just slightly smaller than the ring. I need this part to fit inside of this part. So I need to just make sure that it's slightly smaller. So I need to, I don't know, make this maybe 19 millimeters in diameter. But my 3D printer has like a minimum tolerance. So like there's a minimum size that it can print, and depending on which setting I use to print, and I'm probably going to use like 0.2 millimeters, like a standard print profile. If I go in 0.2 millimeter increments, that's going to work. So right now this is at the, like, it's not going to print 19.5. It might not print 19.5. It might print 19.4 on my printer. Between 0.4 and 0.5 is what I've kind of determined. Anyway, what I think I want to do here then is change this to, let's say, 19.25. That way I give myself a little bit of clearance. So we're going to do this, 19.25, tab, 19.25, done. Now we're going to bring this down somewhat like that. So this is the size of the pin that I want. And this pin will fit inside here. In fact, if we do this number, we can see that it's very close to fitting, like, right in there, right? Yeah. And if we drag it over here and actually do the align thing, we will find that there is a slight bit of room inside of it. In fact, I might drop it down to 19.1. Because millimeters are tiny to begin with, and we're looking at a grid that is very, very tall. And I don't want a lot of play in this, so so my arm doesn't, like, flop all over the place. I want it to be very, very tight in there. So actually I'm going to leave it where it is for now, and I'm gonna make some adjustments here to make this one complete model. One of the first things I'm going to do now is I'm going to move the view to the center here of this. I'm going to put this out of the way. One thing I need to do is move this down so that it's on the bottom, because I can't print that space, and that's cool. I want my swing arm to be a little odd shaped. The other thing I'm going to do is align these here like that. Cool. Now, me personally, this is a 10 millimeter rod. And if you give me just 1 second, I will go get the real part. It's right here. It's right on my printer. And so, here we go. I'm back right now. This is the original. This is the original bracket. And this is the original, like, outside the tube. And this went together, and it extends, and you can see, like, ta-da! I can set this on my thing, and it actually hangs on my printer, and it holds up my 3D printer filament. But so this is a 10 millimeter rod, and this, for a swing arm, that's cool. That's reasonable, right? And then these are the arms, and they kind of fit like the bigger rod here. You can kind of see that. So it's not reasonably unsized. The one thing I will say is I'm going to break out the caliper and say that this part here is 1 inch tall. So So that's going to give you some perspective. So this looks more like 7/16 of an inch. And I'm okay with that. I'm really okay with that for like a 3-inch arm, I think. Which means instead of me making this part taller, 2450, I'm going to bring this part down to 2450, so they're both the same height. Cool. So this is not actually going to go all the way into this pin because the arm is here. The arm is in the way. Yep. Surprise! So even if I make these the same height, they're not going to like interlock at the same height. So this part will never ever be shown out the bottom. It won't be flush even though they're the same height. And subsequently every other arm is going to be like another 3 or 7/6, half an inch, basically another half inch up higher. So I will want to mount this thing, and here I'm gonna, let's see how long this thing is. 90 point. This is the part I want to work on next. Is how long this is. I'm not going to do any math right now because I'm lazy, and I know this is much easier to do. So this is about 3.5 inches wide, and I was going to say about 3 inches, but I don't want to be cocky. So let's see, 3.448. I'm okay with that. I'm going to move back to millimeters. I said I wanted about a 3-inch. In fact, I'm going to shrink this in a bit. Keep going. Nope. As I said, I wanted it about 3 inches. Although now it's starting to look a little goofy, right? Maybe I do 4 inches. Yeah, 330, and it's starting to look a little goofy. I haven't even got to 3 inches yet. So let's move it to all the way out to like 4 inches. 375. 383. One more. 3955. Close enough, right? That's very close. So here's what I'm going to do. I'm going to slide this part out like that. I'm going to go back to millimeters. I'm going to move this part a millimeter out. Actually, I'm going to snap grid to 1/4 millimeter, and I'm going to move it 2/4 millimeters out. And then we're going to see just where we are in inches. 3.974. That's so close, right? Dun dun dun. So I'm not gonna get all wrapped up around the axle on this one. I'm just gonna leave it right there. That's gonna be my 4-inch bracket. That's gonna be my 4-inch swing arm, and it's only one. So let's do this. Let's group. Pow. Pew. Cool. There's my swing arm. So check it out now. We're going to duplicate this, and we're going to put it like that. Now you can see my swing arm actually happening, except it won't ever fit like that. It will go like this. If you see what I'm saying. So the swing arm assembly will swing like that. And in fact, this whole thing will turn like that. And then we can turn each piece, or we can turn it all together. But here's where I want to show you. it's actually going to fit right there, like that. And I'm now, as I'm piecing this together, I'm realizing there is a flaw, because this raised part will not want to, this will not want to sit out here. It will always want to like come back and rest on the pole. It will always do that. So I may need to redesign this bracket to have a flat top to begin with, so that this spins freely without having friction drive it back, or gravity drive it back. And if you see what I'm saying here, basically, if I attach this way, like that, this part is not going to stay straight out. It's going to slide. It's going to want to slide down, which means it's going to spin. So I may need to change my bracket idea, which is why I had a couple of them extra ones over here, because I may have to do this and just put two brackets next to each other, like that. And the other thing I thought about was actually making the clip so that this clips on. I also thought about using the first bracket as the rod, if you see what I'm saying, which is possible. I can do that. Like just have this part slip over my post and flip it all upside down. But then I want this circle part out here because I want to be able to put a camera mount on this empty post, which is still possible over here, but unlikely. Anyway, those are my parts. This is the first iteration of a swing arm. This stuff is so easy to do, and hopefully you caught on to some of the smaller things that I did, like let me go back here. Backing up, yep, right there. See, all these are flat, so that I can print. I have a good print surface to actually print them. And this idea that over here that I had this overhang, I may try to print this over a couple different times with a couple different angles to see if I can get a flat top. Actually, I can do that. Here's... I'm just going to delete that because I don't need that part. I can just print like 5 of these if I really want it. But what I can do is take this apart, take this apart, whoop, take this apart, lower this to 0, snap my grid back to 1, make, oh, whoops, make these the same height, 2450, 2450, like that. Now that this, actually I can leave it up, raised up like that. No, I can't, not the way I'm doing it. $24.50. So now I don't have to worry about, if I flip this upside down, I don't have to worry about my overhang being too steep or not steep enough. So I can do let's do 15. 15. Set this here. Now I'm just going to walk this over so it doesn't move. Whoops. So I got the whole thing there. Cool. Got those two pieces, put them together. Now I'm going to walk this back over. It just got really loud, huh? Okay, those are overlapping, but not really. I'm going to go with my 0.5 millimeter there. Snap back. So now I can print this upside down, and I don't have to worry about this overhang right here. Cool. And I'll have a flat surface on the top for my rod to spin around in. So I can join these together. And instead of trying to print it like this with this overhang, I'm going to flip it over. Like that. I can print that with no problem. In fact, I could have made this whole thing go that way. In fact, let's take it apart. Take this one apart. And do just that. Let's see what happens. Yep. It's got a sharp bevel to it, but okay. In any case, I think I'm done. Either way, I'm going to get that creepy bevel. Well, I'm going to delete this part. And there we go. So now I've got these parts, these two parts here that I'm going to print and make a swing arm. And the super cool part is I have a selfie stick that will go inside this post right here, this thing right here, so I can mount my backup camera and use that to take videos, pictures, and everything else. And I've got a super plan for taking still pictures of every layer. Excuse me. So that will be at a later point in time. But before I go, I'm going to remind everyone. Here I'm going to come back to big camera, big me. We have some design challenges this month, and bring your family in, bring your friends in. If your kids are going back to school, hey kids, come with me. Let's design our own pencil grip. I got this flexible thermoplastic polyurethane. TPU is the easiest way to say it. We're going to be printing this design. So go to our website. I'm going to do it right now. liftandshift.org. Go to the resources. Go to this month at Lift and Shift. You can see the things that are happening. Design your own pencil grip right here. You can do it in Tinkercad. It's super easy. If you don't know how to do it, if you want help doing it, August 26th is the Tinkercad modeling. I will be hosting it. Yeah, that's really about it. I'm going to shut down the music. Super NES. Oh, I'm so distracted by the music. What is this? Oh, it's not telling me what it is. Okay. In any case, it's time for me to go. It's not that I've overstayed my welcome, but maybe I have. Who knows? There. Okay. That's it. I'm done. I'm checked out. I'm gonna grab some water. Do some self-care of my own. I will probably print this in the next week or so if I squeeze it into my printing schedule, and hopefully next week maybe even I'll have an update. If the swing arm works great, you might see me from the big giant beanbag couch next week where I will be using this camera while I play around and show you more, so you don't have to stare at all these obnoxious metals and everything else. Yeah. But yeah, let's not get ahead of ourselves. First, I gotta print that bracket and a couple arms. Easy. Okay. Yeah, I'm done. I'm out. As they used to say in the army, masalama.